Hello students, last time we started the lesson number 13, carbon an important element. We learned the basic information of carbon. The next, what is meant by organic compound and inorganic compound. Occurrence of carbon in free state as well as in a combined state. Properties of carbon. So what is meant by allotropy, allotropes of carbon. So properties of crystalline crystalline forms of carbon that we learned last time, and 3 crystalline allotropes of carbon. So last time we learned the first, that is the diamond. It's what is the arrangement of carbon atoms in a diamond structure, then properties and uses of diamond. Up to that point last time we learned. Now today we start the second crystalline allotrope of carbon is graphite. Now see on the screen what is given. Graphite is found in the natural state in Russia, New Zealand, America. Check that. Russia, New Zealand, America and India. The lead used in pencil is made by mixing graphite with clay. That is not the original one, that is mixed with clay, and that lead is used in our writing pencil. This process was discovered by, what is the name of that scientist given here? Nicolas Jacques Conte in 1795. Remember the name of that scientist. Now structure. Every carbon atom in graphite is bonded to 3 other carbon atoms in such a way that a hexagonal, underline, a hexagonal layered structure is formed. See in this figure. A graphite crystal is made of many sheets or layers of carbon atoms. Many sheets or many layers of carbon present in a graphite crystal. So these layers slip over each other on applying pressure. If we apply the pressure on these layers, then what happened? These layers slip over each other in graphite. So what is meant by graphene? Define graphene. Question asked for 1 mark. So one layer of graphite is called graphene. This is our first question we learn here. Define graphene. One layer of graphite is called graphene. Clear all of you? See what is the originally that graphite looks like, and internal structure of carbon atoms. See here, one carbon atom, consider any one. Suppose we consider this carbon atom. So this carbon is carbon atom bonded with the other 3 carbon atoms. Now see that this is the first one, next one is the second, this one, and third one is here. Consider any. Now here this carbon atom is bonded to this first, second and third. That's why what type of structure of carbon atoms present in graphite? So hexagonal layered structure. Remember these words. Next. Now this activity is omitted in our syllabus. If you are interested, then perform this simple activity at home with the help of pencil, cell and one LED light. So this is omitted from our syllabus for this year only. Next. Now question is asked, what are the properties of graphite? What is the question? What are the properties of graphite? 5 properties are given. Anyway, question is asked in the exam. that is in the form of objective, If 2 mark question is asked, then write 2 properties. 3 marks, then 3, or 5 marks question asked, then write all that 5 points. What is the first property of graphite? See here. Graphite found in nature is black, soft, brittle, means easily break like glass, and slippery like soap water. Second, inside each layer of graphite, free electrons move continuously within the entire layer. And that is why graphite is a good conductor of electricity. Now see what is the magic in nature. Graphite, and last time we learned about the diamond. Both are the allotropes of carbon. Both are made up from the carbon atoms. But the diamond is what? Bad conductor of electricity, because no any free electrons present in diamond. Exactly opposite here. Free electrons move continuously in a graphite layers, and that's why graphite is a good conductor of electricity. Remember this concept. Third property is given here. Due to the layered structure, graphite can be used for writing on paper. Due to the layered structure, graphite can be used for writing on paper. Fourth property. The density of graphite is 1.9 to 2.3 gram per centimeter cube. There is also about the diamond density is given. And fifth property of graphite is given here. Graphite does not dissolve in most solvent. Solvent means most of the liquids we consider. So graphite does not dissolve in that most of the solvent. So these are the 5 properties are given here. Now see the next question is related to uses of graphite. Anyway, question asks, in case of objective, 1 mark, 2 mark, 3 mark, or directly 5 marks. So 5 uses are given here. Now what are the uses of graphite? That is the question. Answer is given here, 5 points. What is the first use? Graphite is used for making lubricants. Second, lubricant means what? For example, what we are putting in chains of vehicles like bicycle or any type of other vehicle, we are putting the oil or grease. Clear? Due to that, easily that wheels about the axle are move. Easily working is occur. For that purpose, graphite is used for making lubricants. Second, graphite is used for making carbon electrodes. In laboratory, for the simple experiments related to electricity, graphite is used for making carbon electrodes because graphite is one allotrope of carbon. Clear? Third one, graphite is used in pencils for writing. This is a very simple use. All of you know this. Fourth one, graphite is used in paints and polish. Now for example, shoe polish. All of you know about this, or black paint generally. So in paints and polish, what is used? Graphite is used. And last, that is the fifth use of graphite given here. Graphite is used in arc lamps which give a very bright light. See here, this is the arc lamp. At the time of Diwali, in the form of lantern, we use this arc lamp. Inside this lamp, we are fitted one bulb and bright light is obtained. I think most of the students knowing about this lamp. So these are the 5 uses of graphite given here. So read the points carefully and keep in your mind. Next. So first allotrope of carbon, diamond, we learned last time. Today we learn the second crystalline allotrope of carbon, that is a graphite, its structure, properties and uses over. Now third one. Third crystalline allotrope of carbon is fullerene. Now see what is the explanation is given here. Fullerene, an allotrope of carbon, is a rarely found in nature. Rarely means very less. It is found in soot and in interstellar spaces. Soot means black color smoke. And interstellar spaces means in between the atoms little space is available there. So at that places, in that interstellar spaces and in soot, this fullerene found. The first example of fullerene is Buckminster fullerene. Formula is given here, C60. Check here. Like a bulky ball showing here. This is a formula. Buckminster fullerene, C60 means 60 carbon atoms present in the form of bulky ball. Check here. Like this bulky ball structure of the C60 fullerene. The name of that C60 is Buckminster fullerene. This allotrope of carbon is named fullerene after the architect Richard Buckminster Fuller. So name of this architecture is Fuller. He found this allotrope of carbon and that's why gave the name to this buckyball present 60 carbon atoms, and from his surname gave the name fullerene. Because the structure of a C60 resemble means like a match, the structure of geodesic dome he designed. He designed one like a geodesic dome, like a ball that is showing in the figure. And that's why resemble the structure of this geodesic dome that is designed by the scientist Richard Buckminster Fuller, and that's why gave the name to this allotrope fullerene. Harold Kroto, Robert Kurl and Richard Smalling were given the Nobel Prize in the chemistry 1996 for the discovery of this carbon allotrope fullerene C60. Remember, all that three scientists were given the Nobel Prize. Remember the names of that three scientists given here in chemistry in the year 1996 for the discovery of this carbon allotrope fullerene C60. Next. So carbon C60, C70, check here. C76, C82 and C86 are other examples of fullerene. That numbers indicate here number of atoms present in the form of buckyball. Their molecules occur in small numbers in soot. Soot means black colored smoke. We find out what is the meaning of soot with the help of internet. So their molecules occur in small numbers in soot. So this is our third allotrope of carbon, that is the fullerene. See on the next page. So question is asked here for 2 to 3 marks, like what are the properties of fullerene and what are the uses of fullerene? 3 properties and 3 uses are given here. Now see the first one. Molecules of fullerene are found in the form of buckyballs and bucky tubes also. In the form of buckyball and in the form of bucky tubes also. Second property, there are 30 to 900 carbon atoms in one molecule of a fullerene. See that. What is the variety? What is the number of range of carbon atoms present in this fullerene allotrope of carbon? So there are 30 to 900 carbon atoms. This is the range is given. That much carbon atom present in one molecule of fullerene. And third property, fullerenes are soluble in organic solvents. Fullerenes are soluble in organic solvents. Which are the organic solvents? 2 examples are given here, such as a carbon disulfide and second one is a chlorobenzene. These 2 are organic solvents. In these organic solvents, fullerene are soluble like salt is soluble in water. Getting all of you? This is the third property. Next, what are the uses of fullerene? So first use is given here. Now check that. Fullerene are used as insulator. Insulator means bad conductor of heat or electricity. Second use, fullerenes are used as a catalyst in water purification. Catalyst means that is the agent, that is act as one agent in water purification process. And third use, at a certain temperature, fullerene exhibits superconductivity. At a certain temperature, fullerene exhibits superconductivity. The superconductivity means no opposition for the flow of electron. No loss of electricity occur at the time of electricity is passing from one point to another, but for that purpose that temperature condition maintain and then pass the electricity. So you try to find out little more information about superconductivity or what is meant by superconductor. So that is the third use of fullerene given here. All are getting? So 2 to 3 mark question asked on these properties and uses of fullerene. Next. Next one. So second type of allotrope is a non-crystalline allotrope or amorphous form. Non-crystalline allotrope is also called as a amorphous. In simple word, that is a powder form. Clear? No any special arrangement of atoms of carbon in this non-crystalline form. Crystals are not properly formed. The arrangement of a carbon atom in the form is not a regular. Clear? Not a regular arrangement of carbon atoms present in non-crystalline forms of carbon, such as coal, charcoal and coke. These are 3 given here. What are the 3 different forms of non-crystalline allotropes of carbon? So coal, charcoal and coke are the non-crystalline forms of carbon. So question is asked here about the coal. What is coal and explain its types. So coal is what? Coal is a fossil fuel. It contains carbon, hydrogen and oxygen. It also contains nitrogen, phosphorus and sulfur. It occurs in the solid state. So it is of 4 types. What is the first one? Peat. Formation of peat is the first step in the formation of coal. Check here, that is showing. This is the peat type of coal. Formation of peat is the first step in the formation of coal. It contains, underline, it contains a high proportion of water and less than, underline, less than 60% of carbon. What is the percentage of carbon? Less than 60. And water proportion of water is high. Therefore, not much heat can be obtained from peat. Clear? Second type of coal is lignite. Peat was, now check here, this peat is transformed into the second type, lignite. Check the figure that is showing here. Peat was transformed into lignite due to increased pressure and temperature inside the earth. How is peat formed? Peat was transformed into lignite due to increased pressure and temperature inside the earth. Underline, it contains 60 to 70% of carbon. So lignite is the, underline, second step of formation of coal. All are getting? So in first step, peat formation occur. In second step, lignite type of coal is formed containing 60 to 70% of carbon. Remember all this. Third one, bituminous coal. Bituminous coal was formed as the third step. Bituminous coal was formed as the third step of formation of coal. This next one, check this figure. It contains, underline, it contains 70 to 90% of carbon. So percentage of carbon is increases from peat to coal. In peat only less than 60%. In lignite 60 to 70%. In bituminous 70 to 90% carbon is present. And last one is anthracite. Fourth one is anthracite. Anthracite is known as the pure form of coal. Remember, given here, anthracite is known as the pure form of coal. This coal is hard and contain about 95% of coal. So increase the percentage of carbon, and if we burn this type of coal from peat to anthracite to obtain more heat. Clear? More heat is obtained from anthracite, then less to anthracite bituminous, and very less heat is obtained from peat type of coal, because percentage of carbon, you check that, 60 less than 60% in peat, 60 to 70 in lignite, 70 to 90 in bituminous, and about 95% of carbon present in anthracites. Clear? Next. Second non-crystalline allotrope of carbon is charcoal. Question is asked, how is charcoal formed? Only 3 lines are given. Underline. A charcoal that is made from animals is made from their bones, horns, etc. Clear? And on the other hand, the charcoal made from plants is formed by combustion of wood in an insufficient supply of air. That is important condition. It's very less oxygen is supplied in the process of combustion of wood. So charcoal is formed. Only this much information given about charcoal. Next. Now uses of coal given here. 2 to 3 mark question is, what are the uses of coal? Question. Answer is given here. First point, coal is used as fuel in factories and homes. Second use, coal is used to obtain coke, coal gas and coal tar. Coal tar means that is used at the time of construction of a road. That black colored tar is used. That is a coal tar. For that purpose, coal tar is obtained from the coal. And third use, coal is used in a thermal power plants for generation of electricity. So these are the three uses of coal given here. Next. Last third one is coke. This is the third non-crystalline allotrope of carbon or amorphous form also, that is called as amorphous form, coal, charcoal, and third one is a coke. So what is coke? Define coke. Definition is given here. The pure coal that remains when a coal gas has been taken away from the coal is called coke. The pure coal that remains when coal gas has been taken away from coal is called as coke. Only uses are given here. What are the uses of coke? 2 to 3 mark question asked on this topic. So first use, coke is used as domestic fuel. Like our cooking gas used in our kitchen. Second, coal is used as a reducing agent. Means to remove the oxygen from any substance. For that purpose, coke is used. So coke is act as a reducing agent, means oxygen is removed from the substance or in any chemical reaction. And third use is given here. Coke is used in a production of water gas. What do you mean by water gas? So mixture of CO plus H2. CO means carbon monoxide and H2 means hydrogen. So mixture of carbon monoxide and hydrogen is called as water gas. And producer gas. So what do you mean by producer gas? Mixture of CO means carbon monoxide plus H2 means hydrogen plus CO2 means carbon dioxide and plus N2 means nitrogen. So mixtures of all these gases means nothing but the producer gas. So these are the three uses are given here. So today we learn the remaining allotropes of carbon, that is the graphite, fullerene. These two are crystalline allotropes of carbon, and last time we learned diamond. So total 3 crystalline allotropes of carbon we learn, and second point our today's we complete, that is a non-crystalline or amorphous form. So 3 examples are given here. Not a regular arrangement of atoms present in the structure of these non-crystalline forms of allotropes. 3 examples are given here, that is the coal, charcoal and coke. Its properties, types or uses like that given here. Clear? So today we learn about these points. So see the video carefully and whatever the questions given in our today's lecture, today's period in this video, try to write from your textbook. Thank you.